Okay. Right. By the way, hi everyone. Good evening. Thanks a lot, everybody, for joining in. Very happy to see that a lot of people have joined a few minutes even before the session starting. Thanks a lot for showing such a kind of interest and the dedication to join this program. Right. By the way, hi everyone. So we'll wait for a few more minutes until everybody joins, and in the meantime, Vinayak and Tara, we can just check on if they have downloaded a software or practice the HyperMesh, session and things like that. So please just check on that. We will wait and start the session at 5:35.
Sure. Yes, I hope you have gone through the preview course which you have asked you to complete it before attending the session. If yes, you can just leave a S in the chat box. Yes, there will be a slot for interaction in the last part of the session.
Yeah. Guys, whoever participating here, by the way, thanks a lot for joining in again. Because this is going to be a hands-on practical session, you have to have some basic knowledge of HyperMesh, because we're not teaching the very basics of HyperMesh and how to use what mouse to click and things like that. So the session will directly start with the foundation to 2D meshing and stuff. So it's that's why we have given you the preview course, which had like a really good amount of content that you could just watch and practice, so that before you come here to this day, you will have a pretty much hands-on with HyperMesh as a toolbox. So I believe all of you have got it downloaded, and so if it is all set, then by the way, Vinayak, you could just start on the introductions, or else I can also just get it started. I think we are good to start from our side, right?
Hello?
Yeah.
Yes, sir.
Okay, we are good to start from our side, right?
Yes, sir. We are good to start.
Okay, great. Awesome. All right. So, by the way, very good evening to all of you, and thanks a lot, everybody. Almost 42 people have joined, and welcome all of you for taking out today to attend this bootcamp. This 2-day bootcamp on automotive meshing, so specifically focused on 2D meshing and 3D meshing. For the part of 2 days that we'll be covering on the fundamentals of 2D meshing, and also we will have an hands-on practice to make this session happen. We have Ms. Tara, so she's our mentor and also the trainer for automotive CAE courses, and she's a graduate in the background of engineering and completed an MTech and worked in the industry for over 6 years in the areas of automotive. CAE and largely work with Altair toolboxes like HyperMesh, and, radios and OptiStruct and things like that. So it's always a privilege to have somebody who have an experience to teach you, and so that you take away something that is really, really valuable out of this sessions, because a lot of the times it's more about just saying something and marketing a lot of stuff. But here, as we always at Decibels, are intended to teach you more, and to make this session successful, your participation is definitely required. We don't see you in front of our eyes, so whenever the trainer asks if you have completed activities and stuff like that, please say yes or no. And if it is really tough to type in three letters, you can just type in Y, that letter Y, or letter N. So we get to know that you guys have at least finished your steps, and also it motivates the trainer to pick up the phase of the training, and keep it all the things going with a lot of interest in place for everyone. So with that note, I wish everybody to enjoy the whole session, and thank you very much, Tara. Over to you. And over to everyone.
Thank you, sir. Hello all, good evening. Welcome to CAE Bootcamp. I hope you have received the file which we are going to discuss today. And I believe you have already downloaded the HyperMesh software. If you are already downloaded the software, means it's good to go, so that you can start the meshing along with me. And these are the contents of the today's bootcamp, where we are going to start this one, editing the geometry, where I'm going to cover what is the editing geometry part, why we need to edit the geometry. Since HyperMesh is not a design software, it is in CAE software. So does the geometry is required, the geometry cleanup is required, or after cleanupping the geometry, what are all the things to be taken care, then the mid-surface extractions. See, once the geometry is corrected and the things are correct, means why we need to extract the mid-surface, that for only the 2D modeling. Then the refining the topology and what are the elements which are available in the HyperMesh, so that we can create the elements by using the different shapes. And what is an automeshing? As the name indicates, the HyperMesh is a very good tool meant for the meshing side. This is one of the most larger used software overall in the CAE industry, where it gives a very good meshing elements. And the mesh edition. Like what is a mesh edition? See, the AutoMesh is the software, it gives some elements. After that, we need to edit it. Why we need to edit it? And do we need to follow any parameters or a defined set of rules to edit the mesh? Does it really required? Then after that, quality of the elements. See, we are going to build some elements that should be in the defined quality parameters. That means we have some set of boundary, like it's like a tolerance value, or the set of number that is defined for every element which we are using in HyperMesh, that is comes in element quality parameters, that we need to maintain it. Then what are the, if any other additional checks for the 2D elements, that all these things we are going to discuss in the today's class. I hope you already downloaded the HyperMesh software. If not, please visit to Decibels website. There we have posted how to download and install the HyperMesh software. Then before starting the session, as the name indicates, we are using the software called HyperMesh. There we are going to implement, or we are going to create the finite elements, that finite element method. So before creating anything, let's have some basic knowledge or basic idea what are the finite element method. As the name indicates, finite element, I'm going to define something in a defined range. That means the elements which I'm going to create using a software, that is a set of numbers. I'm nowhere using the infinite number. I'm using the numbers which are finite. So how I'm going to create it? Using an elements I'm going to create, or first I'm going to create the nodes, then joining the nodes, that is called elements. Then what are the different methods which we use to create any finite element method to solve any engineering problem. In our academics, we have solved only for it is restricted only for the cantilever beam, simply supported beam, where we are going to solve the problem specifically for the simple problems. But when it comes to the any larger section, when it comes to any of the automotive car or any of the automotive door assembly or things like that, or the seat assembly or a roof thing, or any of the engine sections. So if all these assemblies means we cannot solve in academics. So for doing an for solving a cantilever problem only, it will take so many steps to define we need to draw the SFT diagram and the BMD diagram. All these we need to define it. And sometimes what happens, we need to extract the results for the stiffness matrix. After creating the stiffness matrix, we can calculate the stress values and the strain values we are going to extract, and what are the deformation numbers, that is the X1 and the Y1, where we are going to solve everything. That too for a simple cantilever problem, it is a so lengthy procedures, only for the 3 nodes. But what if we having a larger assemblies, like as I said, roof assemblies, seat assembly, car assembly, or any of the BIW assemblies? It is impossible to solve using the equations. So what we need to do, we are going to use the same thing in the CAE software, there where we can solve the infinite number to the finite number of solution. So this is the reason why we are using a CAE industry. That's why we are using a finite element method. Then what is the requirement of the CAE industry means, in the earlier days and all, there was no, in the earlier days, I'm telling, in the decades later, there was no any CAE simulations. What we are going, just we are designing something and we are building and just we are testing. But it will cost so much of time and the manpower, everything is required. What we can do in the CAE software means, you can define any material, whatever you want. You can define the thickness, how much ever you want. You can play with the material. Say for example, steel material, aluminum material, casting, any of the casting components. So all these things we can solve without any cost. That means without creating any prototype, we can solve all these things in the CAE software only. So this is the concept behind using in CAE simulations. Then what are the finite element method? How it works in the software? See, I'm taking it a simple example of the circle. To draw the circle, I can use n number of elements or infinite number of elements. But same thing, the same circle, if I want to create it in HyperMesh or any of the CAE software, first I need to create the nodes. Then the entity of joining the nodes is called elements. So I'm going to define the infinite number of nodes in this circle to a 3 lines or 3 nodes. Then how many number of nodes you can divide it, or discretizing, or then joining the nodes is called elements. Basically, the finite element analysis means it is discretizing the component, or it is dividing the component to a no number of nodes or no number of elements. So this is the concept behind the finite element method. That means we are receiving some component, we are dividing into no number of nodes, and we are joining that nodes with the defined shapes in the HyperMesh, that what we call meshing. So let's start discuss about the component. The image what you are seeing in the presentation, it's a decklid component. This is one of the main component where we are going to store all our accessories, or this is a major door that is in the car part, where we can like, this is very important one of the part. For this door, we are going to do some crash test. We are going to do, say for example, you are parking in some area. By mistakenly, what if you are going to hit some pole, or when you are going to hit some, like when you after something wall or something like that, we are going to do some crash test. We are going to do durability test also. We are going to do all these tests will be conducted for this decklid. In a normal words, we call it as a dicky, but in the terminologies, we call it as a decklid. See, this component is a very big component. As I said, it is having so many features in it. We'll show one by one in HyperMesh. So first, I am going to extract the mid surface. So before that, let me show the component, how it looks in HyperMesh. See, this is a component. This is the decklid component. See, and as I said, to use any CAE software, it is all depends on your system configurations. See, sometimes what happens, if the memory of the RAM, it is not up to the mark, or if you are not having any graphics cards, the system may take few seconds to rotate or to turn the model. So it all depends on the configuration of the system, what you are using. See, as I said, this is a decklid component. Here, we are not going to teach like hands in the HyperMesh. I am directly going to the topic. See, this is called the ribs in HyperMesh. I'll just give an overview of the geometry specification, what it having. See, these are the ribs where you can find many ribs that obviously we have seen practically, we have seen the decklid component in the car. It will be having some lock. Here it's going to lock. Here it will be having one hinge where it going to lock. Then these are the pressing clips. In other words, we can call it as a hot dogs. See where we can see. I'm just zooming the area. See, and these are the very crucial sections in the decklid where we need to create elements by extracting the mid surface. By extracting the mid surface. See here also you can see the ribs. And after viewing this image, you can go and check any of the car decklid. Definitely you will find the same geometrical shapes are the same, if not 100% same, the same things, ribs. See these ribs definitely you will find, and these clips, it should be there. See, these are the clips. Definitely you will see it in a practically in any of the car decklid. See, this is how the big component. And where we are seeing, no, this line means it is a shade between the two edges. And as I said, what is the geometry corrections are enclosed, but what if you not, the geometry is not completely. Let me delete some surface and I'll show you. See, I'm deleting this surface. You can observe. See, till here it is green only, but here the surface is missing. If the surface is missing, so why the geometry cleanup is required in HyperMesh means, after you received any model or any geometry after you received, we need to go thoroughly with the CAD. If the geometry is having any unconnected surface, example, this is the unconnected surface, or any missing surfaces, this comes under in the missing surface only, the unconnected or the missing surface, or if the geometry is duplicated. Why I'm telling means, as I said, the model of the any of the geometrical shapes is depends on your system memory, and it depends on the system memory. If the surface is duplicated, obviously it is going to take the double time. And when when the surface is duplicated or the geometry is duplicated, we are going to get the mid surface. What we are going to get, it may be miss, like what to say, the mid surface may not come properly. So these are the basic checks we need to review it before creating the mid surface. So how to review it, I'll just showcase it. See, I'm keeping the geometry in the wireframe mode. Currently I have kept it in a shaded mode. This is called the shaded mode. If I'm going to keep it in wireframe mode, this is how the geometry looks, where you can see all the green lines, but here the red line is highlighting. It means here the geometry is missing. So you can see it. I'm just keeping in one standard view, and we can visualize the component. We can see all over the green lines only. It means every line and every surface is sharing between the adjacent surface. Nowhere it is unconnected. You can observe thoroughly, but here it is not connected. And this is a simple case one. So how to correct it? Go for quick edit. I'm just going to correct this one. I'm going to just fill it. See, that's all. It means I'm going to fill that surface. Now, if you're keeping in a wireframe and you can check the model. So why I'm editing the geometry before extracting the mid surface means I need a proper mid surface. So why the mid surface is very important in the 2D meshing? Basically, the 2D meshing, what we are going to do today, we are not going to create on this top surface. On this top surface, we are not going to create. We are going to extract the mid surface. So why we need to extract the mid surface? Basically, the idea behind to extract the mid surface is when the component is plastic. See, we have seen the material, as I said, steel, aluminum, or plastic material. So for these materials, we are going to extract the mid surface. And when we need to create the 2D elements, we need to extract the mid surface. When the thickness is very less, like compared to the casting component. A casting component in the sense, compare this this decklid with the engine mounting component, where the engine looks very big. It's look like one box. Like there, for that component, we are not going to extract the mid surface when the component is within the defined thickness. So for those component, we are going to define the thickness. So you can ask me, what is the thickness? See, this is called the thickness, or in your academics, we call it as a width, the width of the rib. Here we call it as a thickness of the rib. So when the component is plastic, when we are going to create only the 2D machine, and when the thickness is defined within the range, then we need to go to extract the mid surface. On that mid surface, we are going to create the elements. So this is the basic idea behind why we need to extract the mid surface to create the 2D elements. So we have learned how to correct the geometry. Then we'll move to the mid surface extractions. Since this component is very big, I'm going to take only this area so that we can focus more in this section. I'm going to share the new screen. See, I have taken the model, what we have shared. This is one of the important part in the decklid component. So this component is defined. That means I have, as I said, if I'm keeping this component in a wireframe mode, I'm not seeing any red lines. Now this component is ready to extract the mid surface. So how to extract the mid surface? See, when we are extracting the mid surface, there are three options are there: offset planes, offset plane, and offset. As the name indicates, offset. Offset means I'm going to divide I'm going to create a new surface, or I'm going to create a new layer between the two existing layer. So that is called the offset. Or one more we can call it as, say for example, the width of the rib is 2 mm, means the 1 mm, in between the 1 mm, we are going to create one more layer. See, this is how the mid surface look like. Once we extract the mid surface for the decklid component, this is how it looks. Since this is a very big component, it will take much time to extract the mid surface. So I have extracted already. But we will work on this, where I can show how to extract the mid surface. See, the mid surface panel is available in the geometry page. Go for geometry page. I'm in the geometry page. Here you can see the option called mid surface. Here the panel is there called mid surface. If you go for mid surface, no, here in the second radio button, you can see there are four different ways to extract the mid surface. We'll go one by one. I'm going to use offset plane plus sweep. I'm going to use. So select the surface. So choose the surface. See, I'm going to use the window button to select all the elements. See, and here you can see this is a model tree. This is a model tree. If I'm going to extract the mid surface, in the status bar, it will show how much percentage is completed. In the left corner of your screen, you can see how much percentage is completed. Since we are using the first option, say extract. Okay, the mid surface is extracted. As I said, offsetting or extracting the mid surface means the new layer or the new surface is going to create in between the two surfaces. See, here already one surface is there. I'm keeping in a different view. See, here one surface is there. In between these two, one more surface is created. And we'll see how it looks. I'm going to display only the mid surface. See, this is how the mid surface look like. This is how the mid surface look like. But after extracting the mid surface, we need to do the topology corrections. We need to do the topology correction. I'll tell you why. See, I have used the first option, that is with sweeps I have used. This is how I got the mid surface. Now I'll delete this mid surface. We'll do the one more option. Okay, go for the mid surface. I'm using the offset option I'm using. Go for auto extraction again. Select the surface or choose a surface and say extract. Okay, now the one more surface is generated. That is the every time the options of what you are going to use, based on that we will get a mid surface. And you can ask me okay, one more. See, first only we are going to extract the mid surface. Then why the three options are available? So you can ask me, okay, why the different options are available to extract the mid surface means these options will work based on the geometry of the component. See, in a car, all the components are not flat, all the components are not curved. Many of the components may not contain the any the bolt beads, any fillets. Many of the components comes only with the like a fillets and ribs. Say for example, compared to the float component, when we are comparing the floor component with the deckled component, the features are different. When we are comparing the sheet metal component with the headlight, the things are different. So based on the preference of the user, these extractions options are available to extract the mid surface. Now we have used the one more option. We'll see how it came. See, as I said, the different option will work differently. In the earlier, let me save it in a different collector. I'm going to create a new collector. Now switch on the original component. I'm going to extract the new mid surface again to show the difference between. Okay, now you can see this is an extra surface which is created, and this is an like the surface is not required. The surface is nowhere we are required. So how to correct this one? See, I got a good mid surface using a different option. I got a good mid surface using a different option. But what if the in another option also, if I'm getting a mid surface like this? So I need to do the topology corrections. That is what I have mentioned, the topology correction. That means before extracting the mid surface also, we are going to correct the geometry to get a proper mid surface. Geometry correction you can call it of elements, we are going to define the topology correction. So how to do it? I'm just going to split the surface. So I'm going to split it with the lines. I'm going to split. Choose this line. Vinayak? Hello, Vinayak? Somebody is trying to control my screen. Can you check it, Vinayak, please?
Sure.
Okay, I'll go for surface edit. So surface edit option is available in the surface edit in the geometry page. Go for surface edit. You just observe the difference. What I'm going to do. First, I'm going to choose the first I'm going to choose a surface where you want to edit the geometry. So this I want. Why I'm editing this surface? Because see, this is an unwanted area where my geometry is not coming here. So and here I'm not going to create any elements. So I need to trim it or I need to delete. Deleting means I cannot delete directly. So I need this surface to be retained. Say trim. Now trim the surface. See, you can choose the surface first. Choose the surface, then trim it. Okay, the trimming is not happening. Let me check it again. Okay. Select the lines and trim the surface. Okay, now it's trimmed. See, you can see I have just split the surface into two sections. I have split it. Now go for deleting the surface. So you can delete the surface. I just switch on the points. These are the fixed points. So we'll replace this point till here to here. Then we can delete this surface. See, this is an unwanted surface. I'm going to delete. So now till you can observe it, till here only I need the surface. So this is the topology correction we need to do after correcting the, after extracting the mid surface. Now we have learned how to correct the geometry, how to extract the mid surface, and how to do the topology correction after extracting the mid surface. Now we'll move on to the element section. What are the elements which are available in HyperMesh? There are two shapes are available in HyperMesh. One is a triad shape and the other one is a quad shape. In the triad shape, we can do it for the two kind. As we know, that is the linear element, that is the 3-noded element, and one more is the 6-noded element. That means it is a second order element. The first order element and the second order element will be used based on the requirements of the project and the objective and what is the end results, what we are going to look based on these preferences. We are going to use the first order and the second order, or we can call it as linear element and parabolic element. The same thing, or the same name only we have learned in our academics, where we are when the subject called a finite element analysis to calculate the stiffness matrix and all, where we have used the, where we have implemented the parabolic elements and the linear elements. Next, we'll move on to the automeshing. What is an automeshing? So in which panel it is available and all, we'll discuss in HyperMesh. See, so I'm going to delete the mid surface. Set delete. I'm going to retain this geometry where we'll work on this, where we can work on this section. So now there are two kinds of elements. One is a quad element, one is a quad shape, and the one more is the rectangle shape. So where it is available, you can see the automesh panel. Basically, what is an automesh means? Directly going to choose the surface and asking the mesh. The elements, what is going to the software is going to create, that is called the automesh elements. There is no manual work. There is no manual work in when we are doing in automesh. Just by going to and selecting the surface, it will get created. But how it will get created? We should give some inputs to the software or input to this panel, asking, okay, I want 10 elements, 12 elements, so like that. So how to give that? Here it is mentioned element size. Here it has mentioned the element size. So what is an element size? So what is an element size means, why it is required and what is the importance of element size? You just observe. I'm taking this surface. This is a ripped surface, say mesh. See, you have created only the 4 nodes. So what if I'm keeping to 1? See, you can create many nodes. So based on the element size, what you are going to give on that number only, the software is going to calculate. It will calculate to that overall this triangular shape of surface, how many elements it can give based on the element size. This element size is very important, and this element size will vary from component to component, assembly to assembly, and analysis to analysis. So based on these parameters will vary. So every time, like things what I'm going to discuss here, or you can see the somewhere else, the things will be different. The number what we are going to use is based on the requirements of the project. It is not okay for all the complete assemblies or for all the component, it is restricted to these numbers only. No, it is not like that. Here I am going to choose the 3 mm as my element size. Here I have kept the mixed. As I said, if you are keeping the mixed means you can get the triangle. See, this is a 4-noded element and a triangular elements also you can get. So what if you are using the other options? I'm just using the R trias, that is 90-degree trias. See, only the triangular elements will come. So as I said, every parameters what you are going to define, it is not like blindly selected, or it is not like, okay, the earlier project we have used this, and this project also we are using the same dimension, same shapes and all. So it is not like that. So everything every parameter what you are going to define is completely based on the project and aim of what is the project. Based on these things only, the parameters are going to differ. For the 2D meshing, most of the cases, to do the 2D meshing, we are going to use the mixed mode only. Why the mixed mode means there we can have the two shapes of element. One is triangular element and one is a quad element. Based on these two elements, we can create the elements on the mid surface. Okay, you can ask me why that mixed mode only means, where we can see for these surfaces and all, it is easy to create. It is easy to create it. But here, no, when it comes to the rib section, as the shape of the surface only triangular shape. Here, if I'm keeping only the quad means, see, this is how it looks. This is how it looks. So to avoid such situation, and for the most of the cases, we are using the mixed mode only. And it is a preferable way to keep the elements. Using a mixed mode only, we are going to create the most of the cases in the 2D meshing. So this is how, these are the basic behind before doing any auto meshing. Now we'll move on to the meshing. I'm just going to select the surface and asking the mesh. You can observe it is giving me some number. These numbers are called density. This is called density. Here it has mentioned, no, it is called density. You can increase it. It is not like, okay, so auto mesh is given 13 means you can increase it. See, based on the density, the number of elements are going to create. Based on this density only, you can increase or decrease the density by using the left and the right button of the mouse. The yellow ones are called nodes. You can see these yellow ones, no? These are the nodes. See, these are the nodes. Using that nodes only, we are going to create the elements. Using that nodes only, we are going to create the elements. Now we are having some idea how to create the elements. Go and select this one and the shape of the geometry. And basically, see, for a flat surface, the elements looks different. This is a triangular rib. Obviously, the elements are based on the geometry shape of the component. What kind of geometry shape you are going to use? Based on that only, the elements are going to create. So now here I have created some elements. Now we'll choose this one. Go for F12 again. Choose a surface and mesh this one. See, when I'm selecting this one, no, here you can see there are two triads are there. Here you can see there are two triads are there. So instead of that, what we can do, I'm going to refine more. I'm just going to refine the geometry even more. Why? Because to have a very good mesh, I'm going to refine the geometry again. Now see the difference from the earlier to this section, from earlier mesh to this mesh. See, choose the surface. Now mesh this one. See, now directly I'm going to increase one density here. See how the good mesh is. So refining topology means how good the geometry you are having, how good the surface or any of the cutouts or any of the clearing the unwanted lines and all you are having, that much good kind of elements you will get. So this is called the auto meshing. And why we need to refine the geometry or topology refine, you have learnt. See, next we'll move on to the what is in remeshing. So what is in remeshing, I'll show. See, software has given the mesh like this. Software has given the mesh like this. This is auto mesh. Here I didn't do any corrections. Now what I want this node to be here. See, I have created something. I just replaced one node. Now I want a different mesh here. I want a different mesh. So how to do the remeshing? How to do the remeshing means, again, go for the F12 panel. Go for the F12 panel. In this drop down, you can see the elements. First, we have chosen the surface and we have meshed that one. Next, in the same option, you can see elements. Now click on the elements and select the elements, whatever the elements you want. This is the remesh. Remeshing means I'm just trying to alter the mesh what the software is given. And I've just tried it. See, here also you can increase or decrease the density. It is possible. See, I want the elements like this. So drag it. See, you can observe it. The earlier tria is here. Now I'm just bringing the tria upside. Like this, if you want, this is called the remeshing option. So why we need to do the remeshing means all the time the auto mesh will not work. Why? Because sometimes see, just it has given one extra line, no? So to overcome such situations, what we need to do, we need to go with the remeshing option or mesh editor, or correcting the mesh, or correcting the flow, or aligning the nodes, or giving a proper mesh to the exact geometry. So these are the different ways we call it in the industry. So what is an automation? The software, the elements created by the software using only the surface, that is an automation. So why we need to do the remesh? To get it exact properly. You can compare the earlier nodes with this mesh. You can compare the earlier nodes with this mesh. How correctly the elements flow is. So this is how you need to create the elements all over the surface. This is how you need to create it all the surfaces. Now we'll move on to how to create the thickness, how to review the thickness of the component. I'm just going for the mid surface option. In the mid surface, you can see the review option is there. Here you just click on the surface, it will show the thickness of this one. Here it is showing the 3 mm is the thickness. It means you can check it, go for the original surface, switch on the original surface. This is the original surface. Here I'm just splitting one line. See, here to here I'm splitting. Quick edit. I'm choosing this node to here. I'm just going for length and I'm measuring this one. See, here it is 3 mm. It means the software which the extracted mid surface is correct. That means here it is a 3 mm thickness. But it is not the same as per this rib. You can see the manually, you can see, and you can tell me, okay, this rib is having a different thickness. So what is the thickness of this rib? Either you can go by choosing like this. Here it is showing 1.8, or directly switch on only the mid surface, go for mid surface again, review the thickness. See, here it is showing 1.4. That is the variable thickness. For this component, it is having a variable thickness. Now we have created some elements and we have reviewed the thickness of this one. Next, we'll move to the quality parameters. What are quality parameters? I'll show one completed component, how it looks. I have done the meshing for that complete one. Okay, this is how the component looks after meshing. We'll mask this, the unwanted area. Okay, this is how the component looks like after completing the mesh, after remeshing, and after clearing the other things and all. This is how it looks. You can see I have created a very good elements on the ribs. You can see I have created a new elements on the ribs. This is how you need to capture it. This is how you need to create the elements. Just now I have shown like how to create the elements on the rib. You need to follow the same guidelines to create the elements. And here I have split the geometry. I have split the surface to get a proper elements on the surfaces. This is how you need to create the elements. Next thing is quality parameters. See, I'm telling, okay, this is a good element, this is a proper element and all. I'm telling so many things. Does it in a proper way? Or does it comes in the quality parameters? Okay, what are the quality parameters? It means after creating the elements, there are the certain set of parameters which we need to follow for the 2D elements. So what are those quality parameters? Where it is available? The quality parameters is available in the F10 panel. That is in the keyboard shortcut key, F10 panel. Here, there are the different pages are available. We are interested in the 2D page. See, warpage we will check, aspect we will check, and the minimum and the maximum length we will check, and the angles for the trias and the quads we will check. These are the different parameters which we check for the 2D elements. So why it is required? See, as I said, to create the elements on this surface, here I cannot create a perfect square. Perfect square means on the four side, the length should be equal. On the four side, the length should be equal. But for me, all the cases, it is not possible. No? Why? Because the change in the geometry, but I need to capture it. You can observe the elements here. I'm just going to create the temporary nodes. You can observe this element. You can observe this element. you can compare this element with this. See how it is in a diamond shape, and this is not a correct element. So for these kind of elements, I'm going to clear the quality. So now you are having one idea. So why the quality parameters is required? Most of the cases, when we fail to get a proper shape, or when we fail to create an ideal shape of the elements. So what are the ideal shapes? For the quad element, it is in square element. For the triangular element, it is in perfect triangular element. That is the 60 degree on each side. So 60 degree on each side. So in these conditions, we are going to create the elements like this. Here I cannot keep the perfect square. And here also I cannot keep the 60 degree angle or perfect equilateral triangle. So in these cases, if I am failed to create an ideal shape, I'm having some tolerance value, or I'm having a set of degrees which I can make use to create it, to complete this modeling. So where it is available? It is available in the F10 panel. Go for F10 panel. Here 15 degree I'm giving for the warp page. Here the warp page is not failing. Let me create one warp page failed elements. Then you can then it is good to understand this one. Okay. Now warp page means you can observe, you keep it in any proper perfect view. You can see all these elements are lying on one plane. But when it comes to this element, sorry, this node is in different plane. So what is an warp edge means? The amount of an angle which is not being in a planar shape. It means that all these three nodes are in one plane, whereas this node is not on this plane. So it means this node is failing for the warp edge value. So how to check the warp edge value? You just go and click on this element. Here it is showing the warp edge value 28 degree. 28 degree. And the numbers what I'm going to discuss in the in this F10 panel, that is in the quality parameter panel, it is based on the element size what you have given. For doing an AutoMesh, we have used the element size. No, based on this number only, these quality parameters will set. As I said, the dimensions are numbers, are the whatever you are going to give in the HyperMesh. Everything should having certain meaning. Don't define manually, or like without knowingly. Don't define it. So how to clear the warp edge? The same thing. Go for F4. Select the node, or you can select this node. You can translate this one, or else one more option is there. Go for F7, choose the node and choose the plane. So this is the plane I want. See, now this element has moved. So now you can check for the warp edge. The warp edge is no. Here it is showing 0 elements. 0 elements is overall element is 334. 0% is showing. The other important is minimum element length. So we'll check it for 2, so that it will show. See the highlighted elements which are failing for the minimum element length. So how to correct this one? Either you can go for F4, measuring the distance, and give it for 2.01 like this. So now you go and you can check for the F10 again. See, now again also it is showing, or else the shortcut way to clear the quality is in the 2D page. Go for the 2D page. Here you can go for the quality index. Here the QI setting is there. That is the quality index setting. If you go and click on here, go for the page number 4. Here there are the set of the same thing, parameters what we have discussed in the F10 panel. The same thing is available here, where you can define the numbers based on the global element size. Based on the global element size, this will work. So you can define the things whatever you want, and you can clear the quality parameters. Let me put it for some other I'll change the values. I'm keeping for 2. So how to clear it, I'll show. See, if it is failing for any of the, see for example, if this element is failing, it means the green elements what you are able to see, these are the correct elements that are not failing for the quality. So if this element is failing, you can come and you can correct it here. See, like this, you can correct this one. This is another shortcut way to clear the quality. Again, I'm coming back to the warp page, sorry, F10 panel. Now, the other important one is the Jacobian. So what are Jacobian? See, you can, by observing the element only, you can tell me what is in Jacobian. See, this element is failing for the perfect shape. perfect shape of square it is failing. So warpage will fail for the plane and the Jacobian will fail for the perfect shape. It means this element is failing. You click on this element and you can see the Jacobian is available here. It is matching with the 68%. It is 0.68 is there. I am telling it is a 68%, but my defined value is 70%. I want it to match. So instead of matching to the 100%, I am matching for the 70%. Why? Because we need to capture the shape of the geometry. We need to capture the shape of this one. So how to correct this one? I'm going for a quality index only. Here, let me make it for 70 for the Jacobian. So 0.7 I'm making. See, again go for the cleanup tools, place the node. See, like this, you need to work. So like this is how you need to correct the quality of the elements. Or else the one more option is the element optimize. See, like this also it will work. If it is not working, you need to do it on a manual way. See, by adjusting the node, just like dragging and dropping the node. And here also you can smoothen the elements. See, here the smoothing option is there. Here the smooth option is there. Select the elements and say smooth. Here only you can smooth it. And the swapping edge option is there. Swapping means, see, this side to this, and you are swapping. You just swapping the orientation of the triangle. You click on this one. This is how it will work. These are the important quality parameters which we check for the 2D elements. And as I said, minimum and the maximum element length. So minimum and the maximum element length. No? Place the node. See. This comes under the minimum element length and this is the maximum element length. If you go and you can measure this one, see, here it is 1 mm. And if you come and you can measure here it is almost nearly the 4 mm out. So it should not be like this. And the one more important quality for the 2D is aspect ratio. What is an aspect ratio means? See, there should be some value which is in between the minimum and the maximum edge of the element. This is not the defined one. This is not the defined one. So we need to correct it. See, for this much only it is passing, but this is not a correct flow. See, for these two elements, quality is clearing. It is clearing for the Jacobian, warpage, aspect, minimum and the maximum. But still, I will tell this element is not correct. Why? Because the flow is not good. The flow is not good. So you need to align this one. See, by aligning this one, I can tell the element is in the mesh is in a proper flow. So these are the important quality checks which we use regularly for daily projects. Then you can check for the duplicates. So what are duplicates? As I said, if the same elements are going to place on the, okay. Now I have duplicated the few elements. Now earlier the duplicates were not there. Now you can go and you can check. See, this is the important other quality parameters which we need to check. See, duplicating means that there are two set of elements on the same plane on the same node. So we are not supposed to carry the duplicate elements. Why? Because see, for example, I'm giving a thickness of 2 mm means again it is duplicating means it is going to make the component very stiffer. It is going to make the component much stronger. So if the component is so much strong, that then we may not get the proper stiffness, proper stress values. After analyzing this component, if the component is so much stiffer, obviously we will get a less deformation value. So to avoid this one, there should not be any duplicated elements in the model. There should not be any duplicated elements in the model. Then the other important quality parameter, not additional checks, is free edges. Find the edges. So how to correct this one? I'll show you. This is a free edge option. Okay, this is a free edge option. I'm just masking the element geometry. See, here everything is connected. You can see till here everything is connected. But you can, if you come here, no, this is not connected. It means the elements are not connected to the adjacent elements. Elements are not connected. So how to do it? Go on by replacing the nodes. But after replacing the nodes, we should be careful to correct the quality, and it should not be having any duplicates one. So this is one of the important quality parameters, that is checking the free edges. Checking the free edges is very important. And the other one is setting the normals. So normals is available in the F10 panel, shift F10. So what are normals? I want to keep the elements in some orientations. See, all these elements till here it is showing the blue color, but when I come here it is showing the red elements. It should not be like this. Say adjust the normals. See, now it has adjusted. why I need to adjust the normals? No, when I try to apply the load, it should take in a proper way. So everything should be in a single plane. So now I have aligned the normals to a single degree, or else you can check for the vectors. No, that is, it will show the arrow. It means everything is aligned to the single plane. Everything is aligned to the single plane. So these are the important quality parameters and the other quality parameters which we check regularly for the daily projects. Next, come to the how not to mesh. As I said, after completing the meshing, it doesn't mean like, okay, you have done everything correctly. No, even though the elements are in a proper shape, or even though the CAD is, if you are clearing the quality and other additional checks also, as I said, flow is very much important. Flow is very much important. See, this is in single node sharing between the two elements. This is a single node sharing between the two elements. That is a triangular element. This is called opposite trias. This is called opposite trias, and this is not allowed. We are not going to keep the elements like this. This is the wrong way of this is the wrong way. So we want the elements to be like this. Back-to-back trias are not allowed. This is the opposite trias, and this is the back-to-back trias. See, this is the back-to-back trias are not allowed. This is the back-to-back trias. This is the opposite trias. These are not allowed when we are concentrated about the mesh flow. And elements in the corner, it is not allowed. And the percentage of trias is restricted to the 5%. Why? Because see, when we are using a more number of triangular elements in HyperMesh for 2D elements, it will make the components stiffer. As I said, it will orient the results. We will deviate from the result. So for this reason, for example, if you are having 1,000 number of elements, you are supposed to use only the 5% of the element. Overall, if you are 100 elements, means only the 5 elements you are supposed to keep the trias. The other should be the quad elements only. These are the important guidelines we should remember when we are meshing. See, these are the, when the node is sharing between the two triangular elements, this is not allowed. These are the back-to-back and the opposite trias, that is also not allowed. When the trias and the fillets is not allowed, and as I said, we are not supposed to keep any trias in a circular section. In the circular section, we need to avoid it. So these are the important topics which we need to take care when we are doing the 2D meshing. Like a 2D meshing, in the most of the cases for any of the automotive part or any of the assemblies, wherever you go, majorly we are using the 2D meshing only. For the casting components, when the thickness is not comparable with the other two directions, then only we are going with the 3D meshing. Most of the cases, say for example, there are 100 components, means for the at least for the 60 to 70 components, we are going with the 2D meshing only. So 2D meshing is very important, and the topics which I have discussed over here, these are the very important topics, and these are the important checks to be done when we are doing the 2D meshing. And here, no, as I said, the flow should not be like this. The flow should be in a proper way. And that, see here, sometimes what happen, if these elements are not allowed, means if you remesh this area, you will get a 2 trias. When the trias are not allowed in a complete assembly, means we need to mesh like this. When we are allowed to keep the tria, you can remesh this surface with like this. So as I said, all these kind of elements of tria percentage based on the project simulation you are doing, and based on the element size, time required for the project. So one is interlinked with the others. Thank you. I hope you understand this one, what we have discussed in the 2D modeling. Regarding the today's topics and the today's content, if you are having any queries related to the today's module, you can ask in the chat box. I'll answer those. Thank you.